This video is about imaginary and complex numbers. Let's talk about imaginary numbers. So if you've tried to put something like this in your calculator, you would get the answer error. E-R-R-O-R. Like, it doesn't work. The reason it doesn't work is because definition of square root means something times itself gives you the answer. And there's nothing times itself that can ever give you a negative answer. So, how the mathematicians decided to deal with this is they called them imaginary numbers. How you deal with it is like this. So this answer would be square root of negative 1 times square root of 4. Well, square root of negative 1 is going to be defined as I, and square root of 4 is just 2. So the answer to this problem would be 2i. Okay, let me give you some more examples. So square root of negative 1 is defined as I. Square root of negative 1 multiplied by square root of negative 1 is I squared, or negative 1. Square root of negative 1 times square root of negative 1 times square root of negative 1 is I cubed, because there's 3 of them, or it's I squared, because 2 of them make I squared, and 1 more makes an I. So I squared is negative 1. This is really important in your math future. I squared. Anytime you see I squared, you call it negative 1. Alright, so a negative square root of negative 1 times square root of negative 1 is negative 1, and then this is I. So this is negative 1i, or negative I. That's really how you call it. Okay, last one. Maybe I'll stay with red. Alright. Square root of negative 1 times square root of negative 1 times square root of negative 1 times square root of negative 1 is I to the 4th. Or 2 of these guys is negative 1, and 2 of them is also negative 1. Negative 1 times negative 1 is positive 1. Alright, so with imaginary numbers, they always come in this pattern. There's a pattern of 4. I to the first power, I squared, I cubed, and I to the 4th. And then this whole pattern would start over again. Imaginary numbers. Let me show you some examples. So what if you had I to the 14th? Okay, I to the 14th. This is how you figure it out. Because the pattern is a pattern of 4, you divide by 4. So 4 goes into 14 3 times. That's 12. Then you subtract and you get 2. So remainder 2. Alright, really all you care about is the remainder 2. So you go back through all that pattern, like back on this page, you back to this pattern. You go through this pattern, and then you go through it again, and then you really go through it 3 times to get to the 12, and then remainder 1, remainder 2. So remainder 2 is I squared, so the answer is negative 1. So remainder 2 is essentially I squared, and that is negative 1. Let's try another one. What if I have I to the 37? Okay. So, because you know I's have patterns of 4, you do 4 and you divide it into 37. Well, let's see. 4 goes into 37. 9 times. 9 times 4 is 36. Then you subtract and you get 1. So your remainder is 1. That's all you really care about. And if you go back to your pattern, 1 remainder is just I. So you call this answer I. Remainder 1 is just an I. So you call it I. Done. Here's another way to deal with imaginary numbers. So if you got something, this is how I began, the square root of negative 4, but let's try something else. Square root of negative 20. Okay, so because you know square root means something times itself, you know you can't do this problem. So you break it up into square root of negative 1 times square root of 20. This is defined as I. And then I deal with square root of 20. So I break it down like a factor tree. 4 times 5. And then 2 times 2. And then if you remember simplifying square roots, when you have a pair of 2, they come out and become 1. So your answer here is 2I square root 5. All right, one more. Square root of negative 48. Okay, so I break it up. Square root of negative 1 times square root of 48. Square root of negative 1 is defined as I. 48. Oh, man. 2 and 24. All the prime numbers. 3 and 8. 8 is broken up into 2 times 2 times 2. Okay, let's take pairs of 2 and get them out. So this is a pair. So 1, 2 comes out. This is a pair. Another 2 comes out. This 3 doesn't have a pair, so it has to stay in. And the I comes out. So we're left with 4I square root 3. This is where I got the 4. Square root 3 had to stay in. Simplifying imaginary numbers. There you go. That's it.